Welcome to Enlightning. I'm so glad you're here. Thank you for being here. Today we're going to talk about Loki, and we have Nicole with us. Nicole, will you introduce yourself, please?
Hi everyone, I'm Nicole van der Hoeven. I am a senior developer advocate at Grafana Labs, and I'm currently reporting live from Italy.
That's so cool. I I switched into a tech career later in my life, so I've been in tech maybe like 4 years, and I just think the remote aspect of it is the coolest thing ever. I think I'll never
Yeah,
get
I
over it.
agree. It's the best thing. I would really struggle without it, remote or not at all.
So we
I
have
really
some.
love to travel.
Yeah, you're in the right job. We have some friends here. Epic Tralala's here again today. Hello, Epic Tralala.
Hi.
And Robbie's here again today, too, from San Diego. Oh, that's
Hi,
not a bad
Robbie.
place to be for work, whether you live there or for vacation. And Epic Tralala, remember you're in Austria. So we're going to talk about Grafana Loki today. So we've been doing a whole series on observability. We've talked about logs, metrics, traces, but mostly we're talking about expressing the data, like serving it up and then having it scraped. But we haven't talked a lot about how it's stored. So I'm hoping to learn about storage today too as part of what we talk about. We have a hello from Kentucky. Hi,
Hey,
Sean. Thanks
Sean.
for being here. I was born and raised in Ohio, not too far. I'm in Austin, Texas now, though.
Oh,
And
cool.
yeah, and so let's go ahead and get started.
Oh, apparently I'm at Epic Tralala and KubeCon.
There you go. It's a
Oh,
it's a
hi.
it's a
Small
smile.
world.
If you went by Epic Tralala in real life, she might know
Yeah.
who you are.
Hi, I'm Epic Tralala.
Oh, and Pete's here. Hello from Minnesota. Pete was a guest on just recently talking about monitoring Kubernetes.
Hey, Pete.
So let's put some of that knowledge to use here today. What do you say? All right.
Let's try.
So before Grafana Loki existed, what was the world like so that it needed to be created? What were some problems out there? Yeah.
I think maybe we should talk. You said you wanted to talk a little bit more about storage. And I know when I was getting into this world, the first thing I said was, why do you need to have very specific databases, like databases that are just for one type of thing?
Yeah.
And the answer is that you technically don't need to. You can put a lot of data into databases and different structures as well. But if you really want to put a lot of data into it, or you want to have it be somewhat performant when you're querying it, you're going to quickly start running into problems. And so I think that you can use a lot of databases for just about anything, but is it the best one? And maybe it's just like a little bit slower or a little bit less optimized. But when you're running that at scale and you're running it on the cloud, and then maybe let's say one of the driving forces for Loki was what if you have those logs in Kubernetes pods that are ephemeral? So they're there now, but what if, if your solution involved kind of scraping a certain endpoint for it, what if that endpoint no longer exists? What then? There were all of these sorts of problems that at the time weren't really addressed. This was like, I think about 2019 when Loki was created. And the Kubernetes problem was one of the bigger ones. How do you get logs from Kubernetes pods, services running on it, without losing data at some point just because they're blown away? And then there's also the question of storage, because especially when we're talking about something like logs, depending on your logging strategy, some companies just end up with petabytes of data that's logged. And sometimes there are real use cases, like there are real justifications for keeping all of that. So you're going to need to find some way of storing all of that in a way that doesn't break the budget, and it's harder than it sounds. So one of the problems was if you just use block storage or you're saving to a disk, then your ops people might not be too happy with you, because they're probably going to be getting pings at some point saying that you're running out of space, and there was a need to try object storage, for example, so that it would be a little bit more resilient and reliable.
And what about, like, so what I'm hearing is databases weren't optimized for different data types, and now that's a thing that's definitely happened. Even a small performance change can make a huge difference at scale. You need strategies around not losing data. I thought of it a second on how to make that not a double negative, but I think that's the best way to do it. And then I think that one thing that's come up a lot is querying data, and maybe that comes into a performance, like, it seems to me that if different data types need to be queried differently, and if you're optimized for your right data type, then that speeds up the query process. So I suppose that falls under this umbrella.
Yeah, absolutely. And Sean actually has a question here that is related. He says, pre-processing or heavily indexing all these different log formats takes a lot of upfront effort and expensive compute resources. And how much of all that work actually ends up being useful? Yeah, so the traditional way of doing logs is, when you have a log, you need to know beforehand what the schema is going to be. The schema is like the structure of the log. So it could be, you can think of it like a table. You could already identify what the columns are going to be. So you could say, well, the first column is going to be, the timestamp. The second one is going to be the user ID or the server component. So the kind of best practice at the time was to have all of these set up, like you have a data model that everyone agrees on, and then you can have all of your components follow that. That way, when you merge them, there's no issues where the column is like slightly off or anything like that. And if it is, and inevitably there's something wrong, there's, the timestamp is in a different format or a different time zone, or the user ID didn't have the leading zeros in one and it did in the other, or something like that. What Sean is talking about here is that the processing for that can be a real problem too, because there's this extra step to get all of that data into the right format before you can query it as if it's all the same, because otherwise it's just soup. There's no structure to it. At the same time, though, sorry, did you?
In terms of just structuring the conversation, are we still talking about kind of problems in the space, or are we just talking now about how logging works? Like, do you currently need to know?
Problem.
Okay, so this is past tense. You needed to know the schema up front.
There are still logging solutions where you do need to know the schema up front. So the problem with that is it's like a trade-off, right? There's no right answer here. So that's why I'm saying it's not past, because I would never say that that's the wrong way to do it. There's just a design trade-off. The trade-off for having to know the schema is that it can be really difficult to agree to that upfront and then make sure everything is compliant with that. But the advantage of that is that once everything's done, then everything is in the right format and everything is much more uniform and easier to query.
Okay. Do you want to maybe speak to Sean's, like, how much of this is actually useful? Like, why is all of that work to do it across all the different data types, to figure out how to serve it, how to scrape it, how to process it, how to store it, short term and long term? It's a ton of compute. It's a ton of effort. Is it really worth it?
Well, I mean, I feel like I'm kind of biased here because maybe we can talk about how Loki handles this. Because Loki looks at this problem and says, why are we doing all of this? Why do we even need a schema? what if we could have a database that didn't care about the schema at all? What if you could just send whatever you want to it and then just create the schema upon query? So it's fundamentally a different way to approach it. Still a trade-off, still not always the better solution. But it does mean the advantage is that you no longer have to come to this consensus. You don't have to have a data model. You don't have to do the pre-processing that you might otherwise need to do. And then the disadvantage of that is that you are dealing with fundamentally unstructured data, and you have to use tricks to find what you're looking for and make it somewhat structured.
Okay. So I heard that, but I'm not capturing it on the board yet, because before we get into how Loki works or like the details, I'd like to just say what it is. Is it simply storage, or is it more of the logging stack?
It's more of a log aggregation stack that's
Okay.
that's built to be horizontally scalable and available and multi-tenant. I say stack because the core of it is it's a database, but it's also more than that. There are different components because it's really microservices based. So it's meant to have many different components, and then you choose the one that you need and you can scale each one separately.
So when you say components, is there like a collector and
Yeah. So it has things like ingesters, and then it has distributors. There's like a lot of components that are on the write path, meaning, when you're ingesting data, those are the things that it goes through. And then the read path is like actually trying to query and retrieve some of that information.
so ingesters, distributors, storage, query engine.
Yeah.
So Loki is a log aggregation stack what's the rest of what you said?
That is built to be horizontally scalable, highly available, and multi-tenant. I think that's what I said.
Okay.
I'm unused to talking and then having someone write down what I've said immediately. I'm like, did I say that right? Now it's written, it must be true.
I paraphrase a little bit, so yeah. If it's ever wrong, please do say so. So yesterday there is an episode about Thanos, which runs on top of Prometheus, and it works to make it horizontally scalable and highly available. And we talked a teeny bit about multi-tenancy too. Is this a common like trio of things that you're looking to have in each of the three different metric types, or data types, telemetry data types?
Yes, definitely. I mean, this is part of the move towards, microservices and cloud native. These things are really important. And I would say though that Loki is more analogous to Prometheus in this example, in that it is also it includes a data store. It's not just a way to make it more scalable or available. In fact, a lot of times Loki is talked about as Prometheus but for logs, which is true and catchy, but I'm not sure about it because it means it's like defining Loki by another project that you then have to define too. But yeah. So you already had a Prometheus episode, so maybe that's okay.
And then a Prometheus, no. So Prometheus is ubiquitous for metrics. I don't even know of another. Is Loki that ubiquitous for logs? Like, don't we also have Fluent D and Fluent Bit and some other things that also do logs?
Yeah, there's a lot. I think Prometheus would still be more ubiquitous, but also that's kind of the Grafana philosophy that you can always swap out different parts of the stack and use whatever you think works for your use case. And so part of that is that, for example, we do work with FluentBit and FluentD. In fact, you can use those as ingesters to bring data into Loki.
I'm going to put it down here. Prometheus, but for logging. So now that we talked about what it is, now I'd like for you to repeat what you said about how the schema is determined, or not at all, about how it relates to this other type of logging where the schema needs to be defined up front.
Yeah, so the way that the way that Loki works is it kind of flips that entire model of needing a schema before you put the data into that format. Instead, it is made to ingest whatever data you've got in whatever format. Doesn't have to be perfect. It could be, it could be in JSON, it could be strings of arrays of strings, it could be objects. There's so many things that it could be. In fact, it could even be traces if you want to do that. But the way that it imposes the structure is at query. The idea is that instead of doing all of this upfront work and deciding on what it should be like beforehand, maybe you should only do that when you already know what data you're actually looking for.
That's
so we
cool.
call that schema at query.
Does that affect your query time very much? Does it make it a longer to get your?
Yeah. So one of the interesting things about it is that when there's a query that is very complex, and it can be if you're doing the schema at query, Loki actually uses parallelization, and effectively it breaks apart this one complex question into many different components that are all like trying to come up with the same answer. And then it shards all of that work so that the end effect is, even though each one is brute forcing it, it works out more performant.
Oh. And
Jafar Shaikh has a question. Sorry, did you want me to just read these? I don't know if
you're
you
welcome
just wanted to.
Yeah, we can. Nicole is also a streamer, so we have two.
Sorry.
If I didn't have the board here, I wouldn't even be needed.
No.
I'm kidding. Yeah, feel free to address and answer questions. I think that's wonderful.
Hello, Nicole. Is Prometheus different from Prometheus, Loki, or both same? They are different. Prometheus, I can see the confusion because Loki definitely draws a lot of the design ethos from Prometheus, but they are different. So Prometheus is for metrics and Loki is for logs. But in terms of, like, for example, the query language that they use, PromQL, which is the one for Prometheus, was also used as the inspiration for LogQL, which is Loki's query language.
Awesome. Thanks for the question, Jafar. And so, to Sean's point, it sounds like we're like the older way or the other ways to do logging. You impose a schema. You might have to do a lot of processing at the time when you're saving the data to get it into that schema. But then later it's faster to use and it's organized. But with Loki, you're just taking whatever data in whatever formats, and the processing is done to give it a structure at query time, which is more work at query time, but then you're only doing it for the ones that you ever want to see later. You're not doing it for everything you might ever want to see. So even though it might be more work in the moment, it's much less work overall and a more performance system.
Yeah. This is related to just like for general database concepts. When we talk about indexes, and I'm not necessarily talking to you, just to everyone in general, An index is kind of like you can think of it as one of the columns in the database, and it is
Uh-huh.
really a way to find something really quickly. You know,
Uh-huh.
it's like a field, and you know that if you're just looking for that field, then you can kind of ignore all the rest of it. Now,
Uh-huh.
when you talk about metrics databases, they're usually column oriented, which
Uh-huh.
means that they're best for reading down that column. So this is why it's so good for numbers to be in there, because you can say like, I want the sum of this
Yeah.
entire column, or I want the average or the count or something like that.
Uh-huh.
Loki is different though,
Uh-huh.
because for logs in general, they work better if they're row oriented, because
Mm-hmm.
when you're just
Mm-hmm.
looking at that column, you don't really care what else is in the other columns for that row. You're just looking at the values, and it's more of a vertical thing than a horizontal thing. But for
Mm-hmm.
logs, you usually want them to be in context. You don't just want a number, you want the entire log line. So that's why it's better if it's row oriented. So Loki is a row oriented database. And again, neither
I
is, it's like not, one isn't good, worse, or better than the other. It just depends what you're looking for.
um I had never thought of that. I wouldn't have guessed that these two things are independent of one another. I just think of a grid and you could just think of it, you could consider it either way. So I didn't realize that there was even a dichotomy here that you're making a choice.
Yeah, I think you have to make a choice for performance, really, because ideally you'd have both, but then
Mhm.
the index would be huge because you have to store the index separately.
Context. And then I have a quick question on our last one. When we said Loki's more performance, to me, more performant can work in two ways in this scenario. As a system, it can be more performant just because
Mm-hmm.
it's not taking the time in the moment to save things in a formatted way, or in the moment of query time, it's more performant. Is it
Both
is it more
ways.
both? Wow.
Yeah,
Okay.
so the ingestion part, it does that primarily through the minimal indexing. Loki will index the timestamp because that's usually important for a log and it's a time series database. And then it will also index like some of the metadata, the labels that you've chosen, but the rest of the log line it doesn't index anymore. So this is kind of like, instead of storing the whole book, you're just
Uh-huh.
storing the table of contents. So it's
Okay.
significantly less that Loki needs to store in the first place. So that's upon ingestion. And then upon querying, it uses like the sharding, the chunking and sharding that I talked about, where it splits a problem into smaller, more manageable problems, and
Uh-huh.
then uses parallelization so that multiple things are working on it at the same time. And that's pretty much where the performance improvement, or the how why it's so performant.
Um, when you say we repeat, when Loki stores the table of contents, what does that actually mean?
So normally, if you having something that's heavily indexed, having
Mm-hmm.
a database that requires heavy indexation, that would mean that you'd have to store kind of like it's just a metaphor. You would store the whole book, not
Yeah.
just the chapters, but like
That.
also the contents of it, the entire log line, which
Uh-huh.
may or may not be entirely useful.
Yeah.
Instead, Loki removes the bits in between the chapter headings and is just like, okay,
Uh-huh.
let's just have the bookmarks, and then you tell me which one you want to dig into later.
So I guess what my question was, like what exactly though? What does that mean to store the bookmarks in a log line? Like I can kind of picture what a log line looks like.
Yeah.
Am I
It does
storing
the
like the
timestamp.
time?
Yeah, the
Okay.
timestamp and labels that you select.
Cool. And then I want your help structuring the board, not the whole book, whole log line.
Sean
Cool.
Foley has another good,
Thank you,
not
Sean
question,
Foley
but comment.
from Kentucky.
So without keyword indexing like other solutions use, labeling in log data probably deserves some strategizing upfront to make searching more effective later on. Yes, and in fact, a lot of our work when we're working with users is trying to get them to understand what makes a good label. You know, so for example, things that are dynamic are not good labels because they're going to change, and then you'll have so many different labels and they won't really mean anything or help you query. So yes, there are still issues with it. This is the trade-off. You don't have to think about it up front, but then later on you do have to, because remember you're creating this while you're querying, you do have to be a little bit more strategic about how you query.
So the labels are happening at query time, not at log saving time? That doesn't make sense.
Sorry, what do you mean?
I guess from your answer just now, it sounded like the labels are being applied at query time, but they're being saved with the record, with the timestamp, right?
Yeah, so like the timestamp is always there and all of the information is there, but you can pretty much decide what label you're going to use for the query while you're querying it. So you don't need to know that you need it beforehand.
Okay. So I put this under a heading data ingestion, but it sounds like data ingestion and query are two different things, and queries in here, so I'm a little mixed up. But in data ingestion, whatever data, whatever format, structures imposed at query time, and then Loki uses parallelization at query time. So a lot of this is about querying and not about ingestion. Will you help me separate the two in my head? They're kind of mixed up. So if we're talking just about ingestion, what are the important points we needed to know about Loki data ingestion only?
Okay, so just like any telemetry signal, you're going to need some sort of instrumentation method. So that could be something like the OpenTelemetry collector. It could be something we have like a flavor or kind of like a distribution of the OTel collector, which is called Grafana Alloy. That would work too. You could be using like FluentD or FluentBit or Logstash to ingest stuff into Loki. So there is still you're going to have to think of a way to get all of that information into Loki. And Lokis come with Promtail as well, so that's another option. There's a lot of different things that you can plug into that part of it.
Okay. Is Promtail Grafana's Prometheus, just based on the prom?
Yeah, there's so much like overlap between Prometheus and Loki because of the design stuff. But in general, what we would recommend now is Alloy, which is more like the OTel collector.
Okay.
And it can do different formats. So whether it's a Prometheus-based format or whether it's OTel, because logs can come in different formats. It's confusing.
Pete mentioned that during his episode that they could be structured or unstructured. So with the data ingestion and for terms of main points, it needs instrumentation, but then after that, it's whatever data, whatever format, right? Or is there another step in there?
Yeah, no, that's good. The instrumentation is for the components that you want to get the logs from.
Okay. Should we say more about that? What components might you want to get logs from? Just literally everything, like your applications versus your pods.
Could be services even. Yeah, it could be
services.
From pods. It could be network stuff. I mean, I have like have a little thing on here called an Oura ring that's a health tracker, and I get logs from that too. I mean, it could be anything.
You're logging your SRE's stress level.
Yes, important things. Reliability of SREs.
um, our logs, also throughout, as I'm learning more and more about observability, there seems to be a line in the sands between like, okay, this is infrastructure related versus this is observing my app's behavior. Do logs tend to live on one side or the other, or they play both sides?
I think that most people are exposed to logs from the application side because, every developer who starts to learn to code is going to log a hello world. Like that's the first thing that you do. So I think it's the one that more people are familiar with. But actually you can have logs for anything, infrastructure as well.
Okay. So back to data ingestion. Some of this is query stuff. I'm saving the query stuff. So
Are you
row
going to be able
oriented.
to like move it later?
My idea is to transpose the important stuff here and then erase this. Do a query one and then clear the spot for later. So because it's too, I think that's part of my role here is to organize the material.
This is so hard what you're doing. I don't know how you do this.
So we have another question from Kimia. Can we also use vector? I'm going to do an episode about vector later.
Yeah, I mean, yes, you can. I don't know that much about vector.
Okay. I don't either, but there's going to be an Enlightning episode about vector. We'll ask Maxine later. And that's going to be the first Thursday and first Friday in September. Okay.
Great! You're on the ball.
Yeah. So we're going to say whatever data. Okay. Row oriented. Not column oriented. I'm just going to, and then, great. So now we want to think about, I'll get this other one here too, but I want to keep the conversation moving. So now we want to talk about Loki at query time. Is that the next thing to consider?
Yeah.
Or should it be more about storage or?
We could go a few different ways because there are different parts of it. Yeah, so we could talk about the querying part of Loki, could talk about deploying Loki in the first place, or the architecture of it. Okay. Yeah, or storage.
Cool. Loki stores. I don't usually try to transpose. It was, I feel bad about the lag.
Oh, that's okay. Sorry, maybe it's just difficult to follow. Maybe I should think about how things are visually laid out instead of just talking.
It's okay. I'm getting a better picture. It's like at the beginning, it's always a teeny bit rocky because I don't know what I don't know, you know?
Yeah. I can imagine.
Okay. So let's talk about Loki at query time.
Okay. So we talked about indexes already. And in Loki, a label is actually a type of index. So it's kind of one of those things where like not all labels are indexes, but not all indices are labels, but all labels are indices. And then we can talk maybe about log streams as well. These are just terms that maybe people would run into when they're looking into Loki. So log stream is a separate file on disk. And if for people who are familiar with Prometheus, it's the equivalent of a series. So a series in Loki is a log stream, and it is a combination of these key value pairs, so the label and then whatever the value is.
So, okay. That's called a log stream.
Yes.
And what is a log stream?
They are unique combinations of key value pairs. It's just a way to, I'm just talking a bit about how Loki stores that data so that we can dig into how we're going to be able to query it, like the best ways to do it.
So a log stream is a unique key value pair
Yes.
that's attached to a specific log.
Yes.
Or-
it's within the log line.
Cool. And then what different, like, in my mind I can think of a log and I can think of a metric. Is the difference, like, a metric has some rules. You have to have time and you have to have a numerical value. And does logging have any rules of what it has to be a log?
So that's the problem with logs, that metrics are more specialized than logs, because logs can include metrics. And in fact, one of the reasons why, you know, if you just, for someone who doesn't have anything, like for a company that doesn't have any, that isn't storing any telemetry signal, I think a very strong case could be made to start with logs. And the reason is that they can take everything. So with something that's very metrics based, you can't really, you know, put a lot of log lines or trace information in there. But the reverse is true, that you can, and in fact we have lots of dashboards and stuff where we demonstrate that everything is a log, everything goes into Loki, but you can transform that to get metrics.
Okay. That's an interesting problem that I see come up over and over again, because people, I think as an industry, are really starting to understand the power of observability and wanting to implement it. But pretty much, best I can tell, most of the time, people first have their whole system already running and doing its thing, and then later want to add observability into it. And so how do we first get our foothold in how do we start that process? So
and sometimes people get a little sidetracked by tracing, which is super cool. I love tempo and distributed tracing a lot, but it is very specific, and it's a kind of like a niche use case. I would start with logs, but probably you already have logs. If you're running some sort of application, chances are you're already collecting logs somewhere.
So Loki at query time. Loki uses parallelization at query time. So basically, and structure is imposed at query time. So can you give me an example of what this would look and feel like? Like, when I want to ask a query, what does that look? How is it different in Loki than if it's stored in a more rigid way?
Yeah, so we can talk a little bit about LogQL. LogQL is the query language for Loki, and it is what enables you to impose some of that structure. It's kind of like, I mean, effectively, you're still just searching. It's the same thing in that you're searching for certain keywords or labels, but you can also transform that data while you're searching. So, you know, you can turn something into a metric, or you can replace some parts of the log line, not in the actual record for it, but just for the query, so that you're kind of grouping things together. Because of that, the queries can be quite complex, and the pipe means that you can keep adding onto it, and it can be difficult to get started with, for sure.
Oh, okay.
This is one
So,
of the disadvantages of this kind of approach, because you're trading, heavy storage costs or complexity at the front of this ingestion process, and you're trading that in for complexity in the querying.
yeah, there's a law, some sort of law. There's some amount of complexity that can't go away. When it's easier, it could just go on to the user. So the advantage is it's very flexible, but the disadvantage is that it's complex and difficult to
It's
learn.
the LogQL, yes.
Mm-hmm.
It is definitely its own thing that you people struggle to learn, and there are ways around it. There's like graphical query builders that you can use, and then we have something called Explore Logs, which is an OSS feature. You can just enable it within Grafana at least.
Mm-hmm.
That kind of already spots some patterns for you and then generates graphs based on it. So there are ways to kind of bridge that beginner gap, but yeah, LogQL, you can do a lot with it, which is its selling point, and also something that can be a bit daunting when you're just starting.
Cool. So we instrument whatever we want logs from. Loki uses that to collect the log data in whatever format. And then we can query the data using LogQL, which is flexible but complex. And overall, it's a more performant system because it uses parallelization at query time to add the structure at query time that it didn't add during ingestion time, which is the more traditional way of doing it.
Yeah.
Is that the gist of everything so far?
Yeah, I think that was good.
Awesome. And so what aspect of Loki is important to know yet next?
We maybe could talk a little bit about the deployment of it.
Okay.
Because there are a few parts that you need to be able to visualize, to complete the whole cycle. You're going to need, some service that you want to get the logs from, the log ingester. We kind of talked about that already. And then the querying part of it, there's still deployment of Loki, and then visualization and storage.
Okay.
So maybe we could talk about different ways to deploy it.
Okay. Sounds good.
So there are 3 different kind of modes for deploying Loki. And the way we think of it is that you're kind of right-sizing it. So if you want something really simple, like you're just trying it out for it's a home lab or something, or it's a learning experience, then there is a monolithic mode. And these modes are like flags that you can set for which one you're going to pull down, and what format it's going to, the structure of the different components. They do ratchet up in complexity though. So this monolithic one is the simplest one.
Simplest. Cool. We have a question. Unlike the heavily indexed solutions, it only indexes metadata. With the label rules, how does it get fast? Can you explain a BigQuery concept in Loki? Thank you.
Yeah.
So I would like to attempt an answer, and you can make it better based on what you've just taught me. So Loki uses parallelization, which I'm having trouble saying, at query time.
I know, right?
So all the different aspects of your query is looking for all of that at once. And so therefore it's more performant, even though each process is brute forcing it. And overall, it's more performant both at query time. That way of doing it is more performant than the heavily indexed solutions. but also in your system as a whole, it's more performance because you don't need to take the processing needed to get logs into the correct format as upon ingestion. You're waiting until query time to do that processing and only doing it with stuff that's going to get touched later. That's eventually queried. How was that for an answer?
That was excellent.
Yeah, it's because you're excellent in teaching.
Oh, I think you're just excellent at understanding.
So there are three modes. Monolithic mode. Are these three modes worth drawing little pictures for?
Sure. Ooh, I can't draw, but I'm interested to see how you're drawing it.
So let's say, a monolithic mode, let's say we're collecting logs for an application. Or are we doing this across machines, or what's?
Yeah, let's
even a
just do it for
monolithic
an
mode.
application. Yeah.
Okay. Well, okay. So how about, because we tend to focus on infrastructure. That's a machine. Should it be, and it's running an application and it's running a Loki? Is that right? And then we did it? Is it that easy?
Yeah, you could, yeah.
I think I want you to direct me some more. App and Loki.
So you'd probably need, in addition to Loki, let's say the OTel collector would probably have to be there.
Okay, see, great. This is exactly what I want. Okay, this is our machine. It's big. And does it fit on there? Yes. So then we have our application. And then the application has the OTel. Is the OTel the OTel collector. Cool. And then we have Loki. Is that correct?
Yeah.
And that's our simplest way of doing it?
Yeah. So in this way, Loki is like a single monolith that has everything that it needs to have in there already. So it's like a single binary. And, that is still the easiest way to do it. You still need the OTel instrumentation, and you will still need a way to visualize that. That's still going to be separate. But I don't know if you want to draw that because it probably wouldn't be on that machine.
The OTel's separate from what?
The visualization.
Oh. Should I make another box for visualization? Is that what you're saying?
You probably would have it separate. I mean, if you're doing it on like your local machine, you could also have the visualization on there.
Is visualization, are you talking about a third-party tool that does visualization, or is visualization part of Loki?
Visualization isn't part of Loki. I would recommend Grafana, but you could have any other visualization tool.
Okay. So with Loki, you can use LogQL, but if you want to histograms and whatever else, you'll need visualization. So you're probably going to have visualization. Okay.
LogQL really just returns the data. The visualization part of it is still a separate layer.
Okay. And that's a third-party thing. And that's all running on one machine. And then I have a question. So OpenTelemetry, I did an OpenTelemetry episode maybe 2 years ago, like a long time ago. And the big thing I remember is that it encompasses instrumentation, like standards around how things should be implemented, what kind of format this data should be in. There's that part of OpenTelemetry, the standards part. And there's also the OpenTelemetry collector, which is a reference implementation. And I kind of feel like those are two different things. And when people just say OTel, I kind of don't understand. Do they mean all those standards?
That's the collector part.
The collector part. Okay.
Yeah. So the agent, that is the thing that is bringing the logs from the application, in this case, to Loki. And
this is a silly question too, probably. But when people say an OTel collector in this context, I get that. But do they mean the literal reference implementation, or do they mean like a something that fits the hotel collector spec that collects just for logs in particular.
In this case, I was meaning the literal OpenTelemetry collectors, like the
Okay.
reference and stuff, but this could be replaced. This could also be Alloy, for example,
Okay.
or, could be FluentBit
Okay.
or something like that.
Cool. Thank you for
Logstash.
taking time to talk about something a little bit
Yeah.
remedial. But
No, I don't
it's
think so. I think this is important because it's like a key part of the whole ethos of Loki that it's not like if you use Loki you have to use these other things. It's you can really mix and match them. That's the whole
yeah,
point.
I like that. Okay, so we have 3 modes. We talked about monolithic mode, the easy one,
Yeah. So
quote unquote.
we have like a small box for Loki, right? But within that, in the monolithic mode, in the binary, there's all of the different components just smushed into one. But we could
Okay.
also go the next step up, which is simple scalable. And simple scalable is like it's the middle ground between going from your home lab setup to full microservices in the cloud kind of setup for Loki.
Okay.
And as we go up the ranks through these 3 levels, it's also going to increase in how much more scalable and available it is, because then you start to break it apart into components that you can size separately. So
Cool.
the simple scalable, I think once you start going through, like I think our rule of thumb was one terabyte of logs, then maybe consider going simple scalable, because at
Okay.
that level, like if you're doing a few terabytes of logs a day, you're going to be running into performance issues, or you're going to be concerned about data loss, or storage would be a concern. And then in that case, if it's more than a few terabytes, it would be microservices that would be better. So for simple scalable, then we start separating things into the read and write paths. So
Okay.
we talked a little bit about how when you're writing into Loki, that's called ingestion,
Uh-huh.
and we talked about how there's like a distributor for it and an ingester. These things can now be scaled separately. So you might say that you want 3 distributors and 3 ingesters, for example. Whereas in the
Mm.
monolith, maybe you don't have replicas of them. Maybe you just have one of each. And you can determine that more when you're using the simple scalable.
What is a distributor in this context?
A distributor is the thing that takes the work. So in this case, it would be logs that need to be ingested into Loki, and it kind of
Uh-huh.
does pre-processing, or it says which one. It's like a load balancer. It determines which ingester is going to get the work.
I think I would like to do like components of Loki
Okay,
recap.
sure.
Yeah.
Yeah, there's a lot, isn't there?
Yeah. Okay. So we have maybe ingester first.
Sure, we can do that. Um, do you want to list them all first, or?
I like to write it first and then what it is and then go to the next one so I have the right amount of space.
Okay, sure. So
Thank you.
we can do distributors. So a distributor is kind
Oh,
of
they're different.
like. Sorry,
Is a
what?
distributor a type of ingester? Ingester?
No, they're different.
Okay. Do you want to do distributors first before ingesters?
Yeah, let's do distributors first,
Okay.
because they're really the first port of call that accept these logs.
Oh. See, already I had it backwards.
Yeah.
Okay.
So the distributor, you can think of it as, I'm actually making a video where we're describing logs as in actual logs, as in the dead trees, basically.
Beavers, yeah.
Yeah,
Yeah.
and the distributors would actually be kind of the trucks that carry those logs to different facilities. They're the ones
Ah.
that get the logs first, and
Uh-huh.
each one can only handle so much. You know, the space on a truck is finite. So
Uh-huh.
it's not like it's not just one truck that's going back and forth. It's probably multiple ones, especially in the simple scalable mode.
Uh-huh.
And it's also the one that determines through something that's called a hash ring, but really what it is it determines which of the ingesters is already full. It's a
Uh-huh.
load balancer and says let's route these logs to this ingester.
Uh, so when I did a Jaeger episode, and also even in Logging Operator, we talked about back pressure, the problem of back pressure, where something's producing your telemetry data faster than your database can receive the telemetry data. And so is this what distributors help with? Yes, that's the problem
Yes.
distributors are solving? Okay. In Jaeger, I
Yeah.
believe they said they use Kafka. It's common to use Kafka for this function. Is that familiar to you? That's what.
Yeah, so it's for real-time streaming. This is not that. This is more like a load balancer directing
Okay.
traffic. So it's less like a stream. Loki is push based, so it gets sent intentionally to Loki.
Okay. Is that and where would I put that Loki's push based? What does that fall under? Anything in particular yet?
Probably ingestion,
Okay.
because the things that we talked about, the collector, the OTel collector or Fluent bit, that would all have to be pushing logs to Loki.
Cool. So we have a distributor. Hi, Ganatech, by the way. Welcome. Glad you're here,
Hi,
friends.
Ganatech.
Hello.
Yay, Loki.
So we have our distributor. Great. And it's like a load balancer. It's the trucks that drive the literal logs. And then
Yeah.
ingester next.
Yes, ingesters next. So they're like, you know how when the logs come in, they still have bark on them. We don't see bark on like furniture, and
Yeah.
we don't see, you know, bits of branches that are still there or leaves that are still on it. Ingesters are the ones that kind of prune everything. So
Okay.
prune the unnecessary stuff and
Uh-huh.
make sure they're much more manageable. So it's not like this really long, like it's not the entire tree that's there.
Ravi, hello, Ravi, asks, is the distributor doing any sharding? What is sharding, please?
So, this is complex. Okay, so sharding is essentially. I'm going to explain this in common sense. I might not use the technically correct definition, but the way that I think of sharding is basically it's taking something that's very big and sometimes unmanageable, and then reducing it into smaller chunks of it. This could be work. This usually work. So it's usually a complex problem, kind of like what it does for querying.
Okay.
But there is some distribution of it. I mean, for distributor as well. I mentioned a hash ring. I don't know if we want to really get into that, but basically the distributor is also charged with assigning different parts of assigning an ID to different log lines that come in, and using that, it then decides where to send it. So it's not the sharding of work. Well, you can It is work in the sense that it is log lines that's being rerouted places, right? But it's not really, I think, technically sharding in the sense that it's the same problem, just in smaller chunks.
Okay.
So it's
And with the
difficult to
ingester,
say.
I understand that you said like it. I understand like, oh, it removes the bark or it makes the data nicer. Can you be like more specific, or maybe give me a technical word, or help me attach that to real life, to what you mean exactly?
Yeah, sure. So when the ingester gets one of the logs, it also like it builds the log stream into these chunks in memory. So
Okay.
it's fitting things in. It's
Okay.
trying to determine where it's going to store it, basically.
Okay. Is chunks logs into memory an accurate thing to say?
Yeah, it builds the log stream into chunks in memory.
Okay.
Yeah.
Cool. And we have a question.
Kimia Sharif asks, how rate limit is calculated with a number of distributors? It's really dependent on what you're processing. I'm not really sure. There's no specific rate that you can say that it will always process all logs at the same rate. It depends a lot on the workload that you have, and then also the number of distributors, which is the whole point of making something simple, scalable, or microservices mode instead of the monolithic one. So there is still going to be an amount of like trial and error. But if you're saying how would you calculate it, it would be like a timing exercise. You'd calculate how many distributors are there, how many log lines for this particular component are there, and then you would see how many are processed over time.
Interesting. So does the ingester also save the data to disk? It memory chunks it and saves it to disk?
Yes.
Okay.
So, yeah, so where were we? Ingesters. Yeah. So it
Okay.
actually saves it in object storage rather than to disk or block storage, but
Okay.
to memory.
Saves. I'm going to write object
Or
storage.
just saves.
I like, it helps my brain to kind of have like how things are, where's the processing happening, where's the storage happening, what things are talking to what other things. Like those
Yeah.
that helps me build my mental model. Okay, so we have a distributor, an ingester, and what else?
Okay, so we can also talk about the query front end.
Okay.
So what we've been talking about so far is the write path, the process of the logs coming in. Now it's like, how do we actually retrieve those logs?
Oh, cool. I feel like we're running out of room because there's so much juicy stuff to say. So this is the read path. Read path. My pink doesn't show up. Blue's the worst.
Oh, sorry, but yeah, that's actually right.
Oh. Okay, that of course it is.
Sorry, now that you put it nicely on there.
Oh, you give me
This
too
is so
credit.
hard to do it live. You've got a very hard job. I could never do this.
Not with that attitude.
Oh, that's true too. Called out.
Okay, so this is the write path. And then we have, I'm going to do the read path here. Read path. Am I on the board? Yes. Okay. And then we have query. What did you query front end?
Yes.
I hear somebody typing just a little bit.
Oh, that's my mechanical keyboard.
Ah, query front end. Okay, well, and what's that do?
Okay, so the query front end is the thing. So this is already when you're retrieving some of the logs. So this doesn't happen for all of the logs. Some logs are never retrieved, and in fact, you would hope that that's the case, right? So the query front end is the thing that looks at the query and tries to figure out how best to actually retrieve that information. So this is where, we talked about breaking up a big problem into smaller queries, for example, and then executing those in parallel. The query front end is the one that determines whether or not that needs to happen.
Ah. So how best to parallelize,
Yeah.
or whether to parallelize at all? We have.
Yes.
Okay. We have a question from Ravi. Does Loki only save and store to object storage?
I believe so. That is something that you can that is the main design principle of Loki, that it saves to object storage instead of block storage. It's just going to be more scalable that way.
All right. What other components do we have? Now I've made you self-conscious about your keyboard. It's okay. I can also hear you mute. So I think it's less distracting to hear the keyboard.
You can hear me mute?
Yeah, because there's just like a teeny bit of background noise. So when you mute, it's like perfect silence.
Oh, so I should like come up with some more noise to make, I don't know.
I think in StreamYard in the settings you can there's like a background noise like filter.
Yeah.
But
I was actually looking up to see if you could. I was looking up the answer for Ravi.
Okay.
The answer is that you can store it to disk, but it's not. You can, and that's only really recommended if you're running it like locally. So if it were for any sort of production thing, I would do it in object storage.
Great, thank you for that. Okay, what else we got on the read path?
Query scheduler is the next one. So the query scheduler, the query front end is like the thing that, like the manager that says this is what we're going to do and how we're going to parallelize it. The query scheduler is the way that it's kind of like the load balancer, but for the query side. So it determines when those queries are actually going to be run, when those jobs get executed.
Mm-hmm. I have a question. Does it determine, is it deciding, I know it's like scalable and highly available, so is it also deciding like what compute to use?
Yeah, so that would be on the query front end.
Yeah, is a query scheduler figuring out like which compute to use?
Yeah, that would be part of it as well. Yeah, for like determining which workers are going to get the job.
Okay. Which workers get the job? Okay, sure. Get which jobs? Awesome. What else we got?
And then the queriers. So
the querier.
That's still in the right path, the read path. And the queriers are the ones that actually parse those LogQL queries that we've written.
Querier, querier.
Yeah.
And it's
all of these weird words.
yeah, so we got a query, we break it up, we send it a bunch of different places, they all process, and then does the querier put it back together?
Sorry, can you say that again?
With the parallel streams, like we receive a query, and query front end figures out how to parallelize it, and then the scheduler sends it to the different workers, and they each work on their part of the query. And then the querier, does the querier put it all back together?
Yeah, it does. So it actually and does the job. That this is where the parallelization actually happens, and
Oh,
then
okay.
all of that goes back. Yeah, like they all come
Okay.
back
So
together.
front end figures out what pieces to put it into, and scheduler
Yeah.
figures out where those pieces should go, and
Yes,
querier
and when.
and when. Okay. And when. And then the querier actually runs it.
Yes.
It's charades. It's
What
Pictionary
is
and
that?
charades at the same time. Uh, so so presumably the queriers like on different machines. If in a horizontally, there are different queriers on different. So the querier knows which pieces it got, and then it just runs its own pieces, right?
Yeah, it could be.
Okay.
This is the part where it could actually be in the same machine. So, like in the monolith one, for example, it's all on the same one.
Okay. Yeah. But if it's
But
distributed, it runs
ideally, yes, it should. Yeah.
the one or many it was assigned what was assigned to them. Okay. And
And then, I mean, there are a bunch of other ones, but I think those are the main ones. There's a bunch of like,
it's
there's a compactor that makes sure that for storage reasons things are as compact as possible. But that's neither in the write path nor the read path. It's more like administrative.
but is there it feels to me like there should be a component that stitches it all back together.
What do you
Like
mean?
all the queries are done separately, and now we have lots of little bits of information that have been figured out, but now we still need to answer the actual query.
Yeah, that's still just handled within the read path. All of the queries are just stitched back together there.
Okay, cool.
So it's kind of like they're reporting back, and then they're
Okay.
like, okay, let's assemble
Just
this, and then
okay.
and send the logs through that way.
So okay, so the query front end
The
gets it
front
all
end,
back.
yeah.
That makes sense. Cool. And then Ravi has a question. When a query is done in parallel to each worker, how does it handle when a worker dies or does not respond?
Yeah, so that does happen. So this is why it's so important to already build with scalability in mind, and why all of these can have replicas. So if a worker dies or doesn't respond, then that gets reported to the query front end, and they're like, oh wait, hang on, or the, I guess, a query scheduler in this case, like, a job was scheduled and then that worker died, that querier could not do that query. A new
Mm-hmm.
querier needs to be sent the job.
So there's somebody up higher that's keeping track to make sure it's getting done and giving it to someone else if it doesn't get done.
Yeah, so the scheduler is the one that would also be keeping track of it.
Okay. And then okay, so will you explain to me how the simple scalable mode works? And then I'm going to decide whether to draw it or abandon this idea
Oh,
that I want to draw it now that I know that there are 5 different pieces at least in the mix.
yeah, now I'm thinking maybe it would be difficult to draw all of
Okay.
them for
Then
maybe
I
let's just mention that there are the three modes.
yes. So we have our mono, and then it makes room for my face too. So that's a plus.
Oh, sometimes you don't have room for your face.
Oh, I always make sure to leave some. So we have the monolithic mode. That's the simplest, and it's good for getting started. And then we have what's called the simple scalable mode. Is that what that's the
Yes.
second one's called? And what's a
Yeah.
use case for that one? When would you want to use a simple scalable mode?
Well, that's the one where it's like more than a terabyte of logs per day. This is a rule of thumb. Of course, you can always jump straight into it if you really want. But something where it's maybe a simple application, maybe it's like a home project that's more than one component. Maybe it's multiple machines. When you start doing that, then anything where you think, oh, actually, I'm ingesting a lot of logs now, and I need to care about where I'm putting it, and when you start to care about how quickly the responses are returned, the query results are returned, then you would go to simple scalable. And the difference between the monolithic and the simple scalable is that, you know, how in monolithic it's just one giant thing, it's just one Loki, and everything, all of the things we talked about are just smushed into that plus a few other components. With simple scalable, they're kind of separated now, so there are different read targets, and then there are write targets. So like the read one would have the query front end, the query scheduler, and the querier, for example. And then they're kind of separated that way into their function, read or write, but they're still kind of grouped together.
Okay. I'm into read and write. Okay. And then our third one.
The third one is microservices. So that one's like full, every individual component for itself. You can scale it up or down as you want, and you can have replicas if you'd like. It's also the most complex.
Mode. Yeah. So complex, and then all Loki components scale independently.
Yeah.
Yeah. I think this is a nice way to break it up.
Yeah, you could draw it, but then it would take up so much space because there are a lot of components.
Yeah. And I just mean from a system design standpoint.
Oh, I thought you were talking about your visualization.
I don't think I've seen, like I've seen the model where there are lots of small things that are composable. I've seen that a lot of times, but I haven't seen where they give you a middle ground where it's like, hey, we've kind of chunked it out into this way, and it's still composable on a smaller scale, or you could have full complexity, and I like that.
And it makes sense to separate it too between read and write, because normally those are different. You would normally want to scale all the read components somewhat similarly to the other read components anyway. So the simple scalable just groups them all together.
And then Ravi has another good question. Is there a method to auto scale the Loki components?
There are ways to do it. Like if you're using Kubernetes, it kind of depends on what you're using, how you're deploying Loki. So if you're doing it on your local machine, then no, I want to say no. But yeah, you can, if you're doing it on Kubernetes, we have like Helm charts that'll show you like a standard configuration for it. And then you can also assign like resource limits to it. And then that's probably the best way to go.
Cool. What else did we say we wanted to talk about? I forget now.
We can do visualization.
Okay. Let's do
and we can also do storage. Which one would you like to do first?
Oh. let's do storage first. I feel like visualization is the reward for a job well done with all this the rest of this
Okay.
stuff.
Well, I mean, for storage, it could just be like options. Do you want to list options? I don't know. There's a lot to really write.
There is a lot to write.
I don't know if there is a lot to write.
Oh, okay. Yeah, tell me about storage at a high level, and then I'll think about what to write while I listen.
Yeah. So Loki is going to need a sort of separate object storage for any production-based workload. So you could
Okay.
use like S3 as well. You could
Mm-hmm.
use MinIO. A lot of people use that.
Mm-hmm.
Google Cloud or Azure. And then, as I found out, you can also do it on disk when you're running locally, which I almost never do.
So Loki needs object storage in production. So you wouldn't write locally to a disk in production, would you?
Sorry?
Would you write locally to a disk in production?
No, I would not recommend it. No, but that's like you wouldn't want to. That's the selling point. That's an advantage of Loki that it can use object storage,
Yeah. As opposed to what?
block storage, and saving it
Okay.
on disk.
Okay. So, and will you go through the list of the Loki storage
Sure.
possibilities?
S3, Azure, Google Cloud Storage, MinIO, OpenShift.
Okay, cool. Google Cloud Storage. Is that all there is to say about storage?
I think so.
What how long do people keep logs, and is there a way, you kind of mentioned compaction, for example, is there a way to sample logs if you want to save them long term? Are there strategy for long term log storage?
There are. The best strategy is not keeping them in, not storing them in the first place. It's
Love
so,
it.
it's true though. It really is true because that's where it starts. It's so much harder to prune than it is to like be selective in the first place. Right? So
Yeah.
a lot of the issues that people have when querying happen, and they complain about like the performance of the querying, and it's true that it is slow, but also maybe don't store absolutely everything.
Okay.
So there's some like logging best practices where if you're storing log lines that don't have errors or warnings or anything like that, do you really need that information? Are you actually querying it? There are also legal implications to think about. Like, do you need that personally identifiable information? Maybe there are
Yeah.
other reasons other than just performance where, that make you think we don't actually need to store people's gender. So why are we asking for it?
Yeah.
Just,
So-
I mean, that's one example, right? But I do think that there's a lot you can do to cut out all of that stuff in the first place.
That's very insightful. So that's all. So storage is pretty easy to talk about.
Yeah, I think so. I mean, we could talk a bit about the compactor. It's kind of like a trash compactor. So it looks and sees what it can compress, and then it takes them from the object storage and then merges them into a smaller number of files, and then re-uploads that new one. Kind of, it's just really. That's why I didn't mention it earlier. It's kind of like garbage. Okay, maybe garbage collection has a different meaning in this context, but it's kind of like taking out the trash and making sure that everything's recycled. There is a separate compactor for it, and if for some reason you need to, you could also have a replica of that or scale that one up. if you're finding that your use case needs that a lot.
So a compactor, it makes it doesn't lose data, it just compresses it into smaller chunks to save money for longer term storage.
Yes.
And then does it make query times take longer?
No, it's still, because it's still, it's not removing anything. So it's more like it's cleaning it up.
Mm-hmm.
But according to your log retention rules, it could also delete some logs. So it could,
Okay.
if your log retention says you want to keep it for only 90 days and then everything is gone, then the compactor is the one that would be deleting that as well.
Okay. And then how long do people keep logs for real?
Lots of different use cases. There are some, like financial institutions, where they're just bound to hold this stuff for like 7 years or something. They just, depending on what kind of information they're holding. And even within that, it's not like just because they're in that industry, all of their components are under that level of scrutiny. There's still, it's really a per component thing.
Okay. Cool.
Ideally, you would do as little as possible.
I like that. I like that attitude in tech altogether. What's the smallest viable effort for anything?
Yeah. So there's also, because you asked about the deletion of logs and how to store them, there is actually a feature that, okay, I usually don't talk about cloud features, but this saves you money.
Okay.
And I think it's technically brilliant. It's something that's called adaptive logs. And what it is we, because of exactly the problem you're saying, that sometimes you don't know how long you're going to need to keep logs for. So there has to be something, but then it's hard to set in stone a policy. And what if you needed something that was 91 days ago?
Yeah.
Well, too bad.
Yeah.
So there's something called adaptive logs that unfortunately is Grafana Cloud only, but it automatically, it tries to figure out your usage and what you're actually querying, and then it drops other logs that are not important. Super scary. It's on my mind because we tried it in production. We're trying it internally first, of course, before before it's done. So I'm talking about like a feature that's been announced but isn't GA yet. But it's scary.
Yeah. So in terms of talking about collecting only what you need and not more, it's helping you know what you need. It's like kind of collecting everything and then judging your behavior over time what you need, and then dropping what it knows you don't need based on what you've done. So I do like how it doesn't take any like brain power, like no employees toil or to figure it out. Like it's doing that math. It's doing it for me based on real data. But I do get
it's like you think you need that, but no one actually queried it in the last year. So do you really need it? And maybe the answer is still yes, But it's scary, because we flipped it on and we're like, oh God, I hope it works. Hope it works.
I'm hosting with my friends a clothing swap tomorrow, which if you haven't heard of such a thing, it's like you go through your closet, get rid of all your old clothes, but come bring them to the clothing swap, and then we go through each other's old clothes. And then, tomorrow I'll be going through my closet to get rid of anything old. And it is like, if I haven't worn this in a year, I have to give it away. But then it's just like, but I might want it. I don't know. It's hard. I'm attached. Yes, exactly. Marie Kondo. Hi, Ganatech.
Yeah.
Ganatech knows some companies who are legally obligated to keep the paychecks made to employees for up to 5 years. Yeah. There's,
Yeah.
compliance.
Or it could also be like security logs.
Mm-hmm.
You know, maybe you need to know who exactly accessed your logs this time last year, or who
Yeah.
accessed your database this time last year. So it really depends on what kind of logs they are.
Cool. Is it time to talk about visualization?
Sure, we can talk about that. Um, there's a lot that we could. So Loki is essentially a data store. It's a place for holding that data and for also letting you query it, so returning that data when you want it. But it's not a tool that's going to give you the visualization. And I'm such a big fan of, you know, you said at the beginning of the show that you have only been in computer science for a few years, and your background is in photography. I love that. So my background is in economics, not computer science either. So I'm like, I'm right there with you. And one thing that I really learned from my econometrics is that all the data in the world means nothing if you don't know what it means, if there's no way to aggregate that into something that you can actually understand. And you might need to have it at different levels too. So something that you present to a developer or DevOps might be different from how you present it to a manager. So Loki is going to need some sort of visualization layer that there are a lot of tools for this. Obviously, Grafana is the one that it works the best with, but you can, just like with everything else we've mentioned so far, you can swap out different bits of it to use whatever one you're already using.
So it needs an object storage layer. It needs a visualization layer. Let's just try to treat this the same, where we can list off some possible visualization layers.
Yeah, sure. Or I was also going to talk about different ways to like get past that beginner's hurdle of LogQL, because that's what I struggled with. You're learning a language effectively, and it's not SQL and it's not PromQL. It's like its own thing. So I wanted to talk about how you kind of cheat and not cheat, but like.
I have a question. Do you
Sure.
consider querying part of the visualization layer? I feel like, or is it its own thing?
It is. It's there's an overlap there for sure, but for example, we have a log CLI that doesn't do any visualization and just returns data. So that would fall under querying and not under visualization.
Okay.
So that's why I kind of separated the visualization, but you would need to query to be able to visualize, yeah.
Okay, cool. We have a question. Do you recommend using automatic stream sharding in Loki? And what benefits or considerations should we keep in mind when implementing it?
Ooh, I am not qualified to answer this question. I am not sure.
This is a great opportunity to say where people can go if they have more questions. Yeah.
Great. So if you're wanting to get more personalized information, in this case, I would recommend when you ask this question, talk a little bit about your use case as well. Like what kind of logs are you ingesting from what components? Is it on Kubernetes? Is it on Docker? Like whatever. What is your current deployment environment, and including for Loki, and then also the volume of logs that you have, how many streams you have. And then you can go to the community forum. Maybe I can put it in the chat, or it's community.grafana.com, and then there's going to be a Loki section there.
Cool.
Here, let's see if I can post a link.
If not, you can put it in the private chat between you and me, and I can put it in.
Okay.
Yeah.
So the community forum is a good one because it's for users, not just customers. So lots of people who already have had similar issues might be there and can also share their experiences.
I
But
don't know
we
what
also go through that, and our engineers answer those questions.
it has that extra 41-bit, but whatever. It's
Yeah, I know. That's why it's weird,
community.grafana.com.
right? I mean, I think if you remove it, it still works.
We'll find out.
I just checked, it does work.
Okay, if you take out just community.grafana.com. So Loki needs a visualization layer, but let's talk.
So I was talking about different ways to get started with Loki without needing to use a query.
And are we talking about LogQL specifically, or just generally getting started with Loki without a visualization?
LogQL, without using without knowing how to write LogQL.
Okay. Cool.
So I'm going to talk about things that are all open source, but they are going to be using Grafana.
Cool. Okay.
Yeah, so we have something that we call Explore Logs. And this is, I mentioned it earlier, it's open source, you just have to enable it. And it's within Grafana. The way that, for those who don't know, because we didn't really talk about Grafana, the way that Grafana works is that you give it a data source. So in this case, you would say that Loki is your data source. And then it would bring in all of that information. And Explore Logs, once it's turned on, is going to generate a lot of graphs already just from the logs that you already have. So it'll do things like it'll highlight any frequencies, the distribution of those logs, so not just a number, but like how many of them over time there were. And
so, I'm sorry, I don't understand what it is exactly. Is it a plugin for a Grafana dashboard?
It's a feature for Grafana dashboards, yeah.
Okay. Feature that helps integrate Loki with Grafana dashboards?
Yeah, so it auto-generates graphs for Loki, basically.
Okay. Cool.
And it's much more of a visual experience. If you maybe don't know what you're looking for, it's a good place to start, and then you can just like zoom into different parts or click on a particular log that appears in red, and then from there it's already doing actually LogQL queries for you in the background. But it's also a good way to learn. Once you've gotten the view that you like, once you've drilled down to it, then maybe look at the query, flip back to that, and then now you know what query you need to run next time to get the same thing.
Okay. Nice. What's another way to get started with LogQL?
Yeah, so you could also use the query builder. That one is not as visual, but it's still graphical. You can look at all of the labels that are in your data, and then you can sort by that. So you don't have to remember, because part of the problem with the query is you don't remember, you don't know what's in your data in the first place. And this is like a drop-down list of all of the things you want. You can say, oh, that one does not contain production or whatever it is. And again, it's doing the query for you.
How in Loki, so we talked kind of about how logs can come from anywhere. You can get logs from different applications. They each have their own logs, different you can generate logs of the help data of your SREs. You can have logs for all of your infrastructure pieces. And so are all of these, how do you handle the fact that different personas want to see different logs? Do you have to run
You,
separate instances of Loki? Is there a way for to run one big Loki and then you can separate? You can have multi-tenancy. How does that work?
yeah, you can have multi-tenancy, but in this case, what I would do is just still have the same database, say just one Loki instance, and then have build different dashboards. That way, you're
Okay.
not duplicating the data itself because it's still effectively the same data. It's
Uh
actually the
huh.
way you're presenting it that is different.
Okay. Do you? What if you shouldn't? Maybe for either for compliance reasons or wait. What if you shouldn't let like different tenants see each other's logs? Can you block them from each other? Is there any kind of access concern?
Yeah,
Or
there
yeah.
are ways to you can definitely have, if you do want to have them in separate instances of Loki, you absolutely
Mm-hmm.
can, and you probably should for compliance reasons. That would
Okay.
probably be the way that I would do it.
So you can run separate instances of Loki
Yes,
alongside
yes,
each
you
other
can.
if you
Yeah.
need. Cool. Awesome. Did you have more you wanted to talk about with LogQL?
Yeah, I wanted to give another resource because it's, I think, the
Yeah.
third way that I would learn. It is called Grafana Play. I'm putting it in the private chat. It's
Okay.
play.grafana.org. And this is a way to look at a bunch of dashboards that we've already made with lots of logs. This is hooked up to different Loki databases, instances of Loki in different formats. Uh, I think it would be that this is how I learn actually with queries. This is a way to shortcut the deployment and installation and having an application and all of that. If you go to play.grafana.org, you don't have to sign in, you don't have to give any information. You can already look and see what the dashboards are that other people have done, and you can go and look at the queries there, and then you can use those in yours.
So it's a playground for not just LogQL, but for Grafana stuff in general.
Yeah, but there's a lot there that's log. There are a few dashboards actually that are purely made of logs, and you can see how they're transformed into metrics and traces and other things.
Awesome. This is cool. So the way, is there anything else you'd like to say? We have like a teeny bit of space I could fill in down here or a little down here. If you have any.
Maybe, I mean, is it a good space for the community call out?
Yeah, sure thing.
Like, or maybe docs or something like that?
Yes, what would you prefer?
Let's do community so that we can talk to people and people can really ask questions.
Cool. I'm gonna comments, put it back on the screen, but oh, we have a question too. Is there log data enrichment in Loki?
You can
Like,
do like error code lookup. Yes, you can do an error code lookup. You would typically have a label for that, like for the log level, and then you could search for the level equals error or something, or whatever the equivalent is for yours.
I'm trying to get just the community.
.grafana.com.
There we go. Now it's, okay. So the way I'd like to wrap this up, so if you have any questions?
Yeah.
Is I'm going to do a recap of everything you've taught me today.
Oh, wow. Okay.
Yeah, and it doesn't take too long. And also, this is a great opportunity for those of you who are watching to ask any last questions for our expert, Nicole. All right. And then, but let's make sure we have a good big picture. I went from knowing pretty much zero about Loki. I knew Loki was for logs, so I feel like I have a pretty good grasp on it, but it'll really help it come together. Pete Wall agrees that the Grafana community is
Yay.
great. Huzzah! So we talked about before Loki, when people were just starting to collect logs and do stuff with logs, databases weren't yet optimized for different telemetry, different data types. And even because with telemetry, we're collecting tremendous amounts of data, even small performance changes can add up and make a big difference. So we need strategies around being as pretty much as performant as possible, but also strategies around not losing data when we're managing this huge amount of data. And logs, when we're first making databases for logs, databases for logs were structured. So you need to know the schema up front. You're making the table at first. It takes some processing to get logs into the right structure. And then the third thing is it's difficult. It can be difficult to change later as your use case evolves. The good thing about doing it that way is that it's tidy. I wrote tidy. I like tidy. It's united and it's easy to query. So then we talked about Loki and what Loki is exactly. We jokingly said it's Prometheus, but for logging, meaning that it's a full stack. So Loki is a log aggregation stack. So it includes ingesters, distributors, storage, and a query engine, all of which we'll talk about in more detail. And Loki is horizontally scalable. It's highly available and multi-tenant, which we talked about a little bit too. So we broke it into different groups. I think we'll talk about Loki data ingestion first, because that's so.
Yeah.
So you can collect logs about anything. And so it could be about your infrastructure, it could be about your application, it could be all the different parts of your application, like error codes, for example, versus what your application is doing. But so you need to instrument whatever it is to serve up the logs that you want to see. And you can do that with something like OpenTelemetry Collector, where there are lots of examples. So with Loki, though, unlike in the past with logs, you don't need to decide a schema up front. You can collect whatever data in whatever format. Loki's push-based, so you're pushing the data. And the data at ingestion time, it's row-oriented, not column-oriented. Metrics, you said, are generally more column-oriented. Because with logs, you probably need all the context of all the parts of the log. So basically, the way Loki, when upon data ingestion, Loki stores a table of contents, meaning it only stores like the timestamp and the labels, but not the whole log. So not the whole log line. So we said it stores the table of contents, but not the whole book. So that it's more lightweight that way. Then when it's time to query logs, we have the labels. It's a type of index. The structure that we didn't put in here, that structure is imposed at query time. And it's done using parallelization. So it's like a multi-threaded approach. So all the different parts of a query are broken up into different pieces and handled by different processors. And so in the end, Loki is more performant. It's more performant both from an individual query's perspective, like that query is going to be performant, but it's also more performant as a whole system because you're only structuring your data that's getting queried as opposed to structuring all the data at the time when you're storing it. So we talked about a thing called a log stream, which is a unique key value pair within the log line. I have no idea what that has to do with anything now in retrospect. Is that part of how Loki's able to find the queries later? What's a log stream have to relate to?
It's how they're stored. So a log stream is like, so a key value pair is like different labels, and maybe different components would have different labels, right? Or it would have different information. So it determines which ones are like the like ones and then kind of groups them together. That way,
Okay.
when you're querying that, they're already all together.
So how they're grouped. The key value, the
Yeah.
log stream is how they're grouped. And then the query language is in Loki is LogQL, and LogQL is very flexible, but also it can be very complex, which is, you know, a common trade-off in tech, I would
Yeah.
say, in general. So it really helped me next to think about the components of Loki. So we talked about a write path, so how our log's getting written. And there are two big important components there. We have the distributor, which receives the logs from whatever's collecting it. And then it determines the best ingester, like what ingester has good processing power and is available right now. And then it routes the logs to the appropriate ingester. So a distributor is similar to a load balancer. And then we have ingesters, which are workers in the right path, and they build the log stream into memory chunks and save the logs to object storage. And that's an ingester's job. And that's the right path. So as logs are getting created, they're going through those two things. And now they're stored and just sitting already, eagerly waiting to be used and give you information about your system. Then we talked about the components of Loki that are in the read path. So you have your query front end, which is where the query is being made. And it looks at the query and figures out how am I going to break it up? How am I going to parallelize it? Then once that's broken up into chunks, then the query scheduler comes into play. The query scheduler takes the chunks and says which workers are going to get which jobs at what time. And then we have the querier, which actually does the work of running the queries. Now, it's important when you're thinking about these things that there are probably multiple copies of each thing that are running all across different machines. So that's why, like, the querier is only going to run the queries that was assigned to that particular process point. And that's how and then when all of the information gets eventually returned back to the query front end, which returns the answer to the user. And that's how the read path works and the major components. So with that in mind, then we could talk about the different modes of deploying Loki. You can deploy Loki in a monolithic mode it's a very simple way to do it if you're just learning Loki and you have a home lab or something. And it's going to have all these components just wrapped into one Loki deployment, or binary, right? You said it's all one binary?
Yes.
You could also do simple scalable mode of deploying Loki. So if you're using more than 1 terabyte of data, it's probably time to graduate to this mode. And so you have your Loki components are separated into there's a one that handles the whole write path and one that handles the whole read path. And those two can be distributed and scaled separately and as needed to best suit your particular system. And then when you're ready to go full Loki, then you go to microservices mode, number 3, and that's when all of these components are separate from one another. So this is definitely the most complex way, but then you have the most fine-grained control. Again, most flexible, but very, very flexible, but very complex, just like LogQL. So then, so we have it all broken up into each one can be scaled independently of every other one. And then we just talked about a few other things. Loki needs object storage in production. That's where it's going to store for like S3, Azure, MinIO, Google Cloud Storage, and you said OpenShift too. Then we have the Loki compactor, which helps for your data storage to make it take less space. So it compresses data into smaller chunks for storing, but all the data is still there and still queryable. And then we talked about visualization. So Loki doesn't have a visualization layer on its own. It needs a visualization layer. And it's compatible with several, but of course you like Grafana dashboard. And so we talked about getting started with writing queries because it is a barrier to entry, using the LogQL. So there's Explore Logs, which is a feature in that auto-generates Loki graphs. It's a feature in Grafana dashboard. Dashboard also has Query Builder, which is a graphical way to look at all of the labels on your data to see what's available to you. And then we have play.grafana.org, which is a playground for all kinds of Grafana stuff. And then we finally talked about community, and that Grafana has a lovely community, and it's open source. And if you have any questions, this would be a great place to go.
Yeah. That was awesome. Yay.
Thank you. Is there anything you'd like to say or add, or does anyone have questions?
Well, I just wanted to say thanks for having me. This was really great. I've never had the experience of having what I'm saying be written down live. A little nerve-wracking, but yeah, it was great.
If you would have cussed or something, I would have just written it.
Oh, no.
I'm kidding. I'm joking. This was an absolute pleasure. Thank you so much for coming on and sharing your time and expertise with me and with everyone here and everyone who watches the recording.
Yeah, thank you.
Thank you. I'm gonna close this out by replaying the intro music. Yay! My brother wrote this song.
Oh, that's so cool.
So thanks everyone for coming. Thanks all of you in chat who come all the time. I appreciate you. Yeah, take it. You got this. Yeah. We're dancing from Texas to Italy. Doing a dance together. Love it. All right. Bye, everyone. Thank you.
that was, I did not know that was happening.